Hello, welcome back to the channel and this series where we're exploring shapes. And because we're 4 days away from Christmas, today we're going to do an example with a festive theme. So this is a question which could come up in sort of a GCSE level paper, normally about the intermediate level, possibly the higher tier earlier on. And the question is, a cutout of a Christmas tree is comprised of 3 triangles which are all equilateral with lengths 2x, 4x and 6x, and the total surface area of this shape is 25 metres squared, so the facing side of this, I should say, rather than the side on the other side as well. So these 3 triangles add up to 25 metres squared, and the question is, what is x, or find x? So if you're looking at this in an exam, we should break it down into things we know. So there's triangles and we're talking about area. So it's a good idea to write down the area of a triangle. So the area of a triangle is equal to half the base times the height. And in the case of this, we have 3 triangles that are adding together to form to equal 25. So we can form an equation out of that. So we can say that 25 is equal to the area of triangle 1 plus the area of triangle 2 plus the area of triangle 3. So when we look through these triangles, we know they're equilateral. So we know the base for each of these triangles, but we don't know the height. So we're going to have to find the height of each triangle. So let's call the height of the first triangle h1, the height of the second triangle h2, and the height of the third triangle h3. So there's a couple of ways we can find the height of these triangles. Because it's a equilateral triangle, we can split it down the middle to form 2 right-angled triangles, of which we have one side, in this case the hypotenuse. Also, because it's a right-angled triangle, we know what the internal angles of these triangles are, whether they're the equilateral or the right-angled triangles. So this angle here is always going to be 60 degrees. So in the previous video in the series, I used trigonometry to find the height of a triangle. So in this one, I'm going to use Pythagoras' theorem to find the area of the triangle, or the height of the triangle, and then hence find the area later on. So if we start with the first one, we know the hypotenuse here is 2x. So we're going to start off with 2x all squared, because in Pythagoras' theorem we say the hypotenuse, which is c, denoted c normally, is c squared plus the is equal to the sum of the squares of the other 2 sides. So what are the other 2 sides? We know the base of this equilateral triangle was originally 2x. So the base of this triangle, or this right angle triangle, is going to be x, and we're going to need to square it. I'm going to add that to the height, which is h1 squared. So we can rearrange this and find that h1 squared is equal to 4, because we have to take the 2 in the square inside the brackets. So 4x squared minus x squared, which is equal to 3x. And if I want to find what h1 is equal to, I have to square, so that should be 3x squared. And if I want to find h1 is equal to the square root of 3x squared. So h1 is the square root of 3x squared, which is equal to, so we can find the square root of x squared, that's just x, times root 3. So I can now do similar for these other triangles. So h2 squared is going to be the base squared, which is 4 squared in this case. So we're going to have 16x squared, so 4 times 4 is 16, and the x squared, minus 2x squared, which is going to be minus 4x squared. So this is going to reduce down to 12x squared. So h2 is equal to x square root 12. And finally, for the last triangle, which is h3 squared is equal to 6 squared is 36, x squared minus half of 6 is 3, so 9x squared. So h3 is equal to x square root of 27. So I've now found my heights, and I've left them in the square root form. I can convert these with a calculator if I wanted to, but to keep it accurate, I'm going to stick with them in the square root form. I can now start putting this into my equation. So I'm going to start writing this down here because it's going to become quite long. So we're going to have 25 is equal to the area of triangle 1, which is half the base, which is 2x, multiplied by the height, which is x root 3, plus half, so this is now calculating the area of the second triangle, so half the base, so half of 4x, multiplied by x root 12, plus the area of triangle 3, which is half of 6x multiplied by x root 27. So now we just have to multiply through by all of these. So we got 25. So I'm going to have a half times 2, which is 1. So I can leave that as it is. X times x is x squared root 3 plus half of 4 is 2, x squared root 12 plus half of 6 is 3, 3 x squared root 27. So what I can do now is take the x squared outside all of these. So I can do, hopefully I have space here, this is equal to x squared, open the brackets, so I'm having root 3 plus 2 root 12 plus 3 root 27 is equal to 25. So 25 all over this root 3 plus 2 root 12 plus 3 root 27 is equal to x squared. So if I square root both sides, so I can say that x is the square root of 25 over the root of 3 plus the root of 12 times 2 plus the root of 27 times 3. So this is where I'm going to need a calculator to come in for this final part. So when you're using a calculator, we need to be careful with brackets. So I'm going to start off with the root, open the brackets, and I have 25. And I'm going to be dividing that by opening another set of brackets. So I'm going to have square root of 3, which is going to be in its own set of brackets, plus the 2 times root of 12 plus, again in its own set of brackets, 3 the square root of 27, close those brackets, is equal to 1.015, and because we're in meters squared, this is going to be in meters. So we found the length of x, so it means this Christmas tree at the base, or the base of the bottom triangle, is 6 meters, just over 6 meters across, so it's a fairly big tree. Anyway, with that, Merry Christmas and Happy New Year, and I'll see you in the new year with a new series of maths problems.